but the concept it should be the same. All CPU is the same, only the language may be a bit different. Same assembly language, only the syntax may be different. Okay? Now go back to this one. So this one don't care. Okay, this is the theory back in the chapter 1. What is the component inside the CPU? There are 3 things only. One is register. Register is the one, I remember that. Address register, data register, program counter, stack pointer. That's all registers. Benda yang disimpan dalam itu. And then we have ALU, arithmetic logic unit. This is where you have to do the calculations, all the logic stuff. And the last one is the control unit. This is the 3 main components in theoretical for CPU. So you have to remember this forever. The block like that, alright? Okay, go back to this one. Remember this picture? I have to embed this image in your head. So back to the thing. This CPU, inside the CPU there will be registers, and you have to know the size, and you have to know the functions. Okay? The basic things of the register, there are 2 big ones. One is data register. The function is to restore, to store data, because the name is data register, so the function is to store the data. This is the one, data register. The second one is address register. This one. The function is to store the address information. Address ialah locations of the memory outside from the CPU. Remember that? We have the CPU here. We have CPU here. And everything you want to do to the memory here, I draw by using odd and even. So this is the memory map for $000000000, $0000001. So this is the memory location one by one. The last one will be F for 6 digit. 6 digit for hex. So each of the component F means 111 up to here also 111. Total digit is what in binary? How many? Total bits for F 6 digits stand for how many? It's 24 bits. So again, why 24 bits? Because of you have the pins for the address is only 24. So the maximum of location different will be based on the legs for the address address bus. How many? This is from A0 to A24. It reflects the total of memory you can access. Right? Remember that the total memory will be based on the how many legs for address leg, right? So 2 to the power 24. This is the total locations of memory. Sikit you have to understand. Alright. This is the leg. Also data also have a leg. This is data pins. They call it data pins. This is address pin. Data pins only 16. Only 16, right? Data register inside how many? How many bits? Data register. Okay, the label is D0 to D7 is this one. D0 to D7. Not this one, Not this one. So D0 to D7 is you have total of 8 data registers inside the CPU. Only 8. Only 8. The size is how many? 32 bit. So here is 32. 1, 2, 3, 4, 5, 6 bit, 32 bit. You have data pins only 16, correct? So if you want to store the data here to the memory, if you want to store all 32 bits, you have to send twice. Because 16 once, and then another one is 16. Total is 32. You have to imagine that this is very fast happen in the CPU. Again, I repeat, you have 32 bit data register. Data pins only 16. If you want to send this information to the memory, okay, to the memory, you are going to use this pin, correct? So this pin only 16. To send the whole total of 32, you have to send twice. Total means 16 once, and then another one is 16. Means total is 32 complete. Okay? Alright. So far okay? Agree, eh? Okay, now go to address register. Address register, the name will be A0 to A6. Only 7 of address register. A7 is for the stack pointer. This is one chapter. Stack pointer is actually quite interesting but very hard to understand. Okay, so this is very easy. A0 to A6. Address register, you only have 7. A0 to A6, not this one. This is an address pin. Okay, here is the one. Alright, number is 7. Size also 32. Why 32? Because normally in a binary system, you start from 2, 4, and then 8, and then 16, and then 32. Normally it's like that when you learn about binary coding. Okay? So now the size is the same as data register. Correct or not? Okay, you see now, what is the function of the address register? Is to contain the address of the memory location. Memory location is this one. Okay, this memory location is only how many bits? 24 only, the memory location. Because of the limitations of the pin, right, address. So now, your address register is 32 bit. At the end, only 24 can be used. Means that only the first 24 will be used as the address register, address information. The rest from 25 to 32, you don't need to use that because your memory maximum is FFF, that's all. You cannot go more than that. Okay, that is the information. So this is the two big one that you are going to learn today. Understand this is much better. Stack pointer will be one chapter. On the last, I think on the 7th chapter, I think that's the last chapter that I will be with you before I transfer this one to Mr. Bazzi class. Alright? Program counter is another interesting thing. Quite easy also, but you have to understand. Program counter is only one here. And the last one is status register is this one. The size for the program counter is still 0 to 32. Only status register, the size is different, is 0 to 15, is only 16 bit. Okay, inside the CPU, you've got how many registers? You have data registers, you have address registers, you have stack pointer, you have program counter, and you have status register inside the CPU. Okay? Boleh tahan? Okay, back to this one. This is actually the technical things that you can see inside CPU. Whereas, if you open up the CPU anything, you can see like this only. This is a full of transistors. It's a switching thing. The more complex CPU, the smaller the design is. I don't know how many micron right now, I don't know. very small transistor. It's a wafer. If you work in the industry, normally Siltera is actually fabricating the wafer. Siltera in cooling. Cooling, yes. They are fabricating the wafer. Wafer is very expensive, and you have to wear the bunny suit. Do you know the bunny suit? The one like the astronaut one. Why? Because they want to make sure that the room for the wafer fabrication is very clean. They have a standard clean room. If there is dust in your air, that dust can stick inside the wafer, then the whole wafer is gone. This is a big wafer, you know. I mean, the wafer is very big. Then you have to chop it until at a very small, like particular square, and then to put inside the digital components like that. Once if you have chances to go to the industry, let's say in the industrial training, whatever it is, if you have chances to go to this kind of industry, that you will learn more. Alright, Intel never. If we don't have, for Intel, we don't have wafer here. Most of the wafer fabrication happens in US, in New Mexico or Oregon, I think, New Mexico. Another one is Israel. These three areas. Malaysia is doing packaging, where they ship all the wafer. The wafer is completed. Majority of the wafer is not the high-end CPU. High-end means very powerful, like i9, i7. I don't think so they have over here. I'm not so sure right now. Last time they only give the lower type of CPU in Malaysia. The rest will be done in US, if I'm not mistaken. Now I don't know. Right? There will be no here. So okay, so far? Hopefully okay. Okay, now this is again the image, but this is the way how the system going to send the information from the CPU to the memory. In this chapter, you will always have to know that the process of sending up the data from the memory to data to the CPU or the CPU to the memory. This is the information, right? Like for example now, you have data inside this data register. For example, you have data. You have data AA. Okay, you have data AA. AA in dollar sign. AA is how many bit? About bit? 10. This is 1, 2, 3, 4. This is 1, 2, 3. Total is. You have to refresh back the hexa to binary. No, you boleh keluar calculator. You can use your calculator right now. My class have to use calculator. Open up your calculator. This is very important. Very simple. You turn on your calculator. Go for hexa. Type A, and then convert it to binary. Or maybe you just type F, you convert it to binary. A will be 1010, correct? F will be 1111. So each of the digit from hex is 4 bit. Each digit from a hex number is 4 bit. So if I have AA means there is a 8-bit numbers. Betul tak? So let's say for example, if I have a data inside my CPU AA, this data register do not put AA. You will convert to binary directly. But our class, we have to stick to hexa. This is normal. I cannot always use 1100 because if 16, I have to write down everything. AA is enough. Then I have to put, if I use binary, I have to put 8 times already. So AA is actually 2 digit for hexa. So means that if I have AA in the CPU data register, the number will be allocated from here to here, only 8 bit. The number will be 1010 That is the number. The number will be allocated over here. Only 8 bit. The rest of the bit is 0, nothing else. So it means that now you have 1010, 1010. You want to send this information to the memory. Okay, now you look at the memory. The memory size is fixed. Each of the location size is 8 bit only. The location size here. Okay, now you cannot confuse that. The memory size. Each of the memory size is only 8 bit. Okay? 8 bit only. So I want to send this 8 bit AA sent to the memory location address 00000. There are lots of ways to put over there. One thing is you can send the address information to the address bus telling them, the CPU, that the data will be sent to this location. Then it will send to this one. This is the method. The address register is to contain this number if you want to put. This number. The data is inside here. This is the method how to send. This is the address pin. The information of the address where do you want to put the data to here. Then you have to understand again, the registers for data register is 32. The size of the memory is only 8 bit. If you want to send the whole data here from data register 32, how many locations of memory it will occupy? Sorry, how many? So you understand 4, correct. Now you get to understand. So if you want to send the whole information from data register to the memory, you will require 4 of memory locations. I'll show you after this. Okay, so far, okay? Alright. This is just analogy again. I keep on repeating this so you have to understand. We have talked about this one before. Okay. Alright, data register, address register. This is how many memory locations because of the 24 pins. Stack pointer, you just need to read this one first because we are going to have it in one chapter later. Correct counter, the function is, I will repeat it in a few chapters later because when you use that one, you can see what is a correct counter. Status register is another one, very important also in the next few chapters. Okay, now the CPU addressing mode. This is all terms, yeah? This one later. Alright. Memory, the one that I showed you just now. Okay, this chapter, these slides draw like this. I can draw like this, but normally I do not draw like this. I will draw like this. Odd and even, odd and even. You can draw like this, no problem. Because, but normally, why do you need to draw like this? There will be something that you want to see. Because you want to segregate those odd and even. So draw like me. Okay, draw like me. You can draw like this. There will be no problems, but better draw like me. Okay, saya tak salahkan ni. I don't say this is wrong, but this is also better. Right? Okay, this is the one that I said just now. If you want to send the whole 32-bit from the CPU data register, total of memory locations is unit 4, like this. Okay, next one is the terms that you need to learn. The new terms for today, other than byte, is word and long word. This is a new terms. Word bukan Microsoft Office Word, Word for microprocessor and long word. What does it mean? Byte, how many bit? 8 bit. Word is 16 bit. Long word is 32-bit. That is the term that you need to learn today. Bit is 1, byte is 8, word is 16, long word is 32. Nibbles, I don't really use this term. In this programming, we only use byte, word, and long word. Okay, so far? Yes. Okay, this is all the Mawali reference. So far the slides, okay, but we have to understand better. So for those who have laptops, turn on your laptops. For those who don't have the laptop, turn on the PC. We are going to do the simulator. You need to understand better. Turn on the PC right now. For those who have turned on, you need to open up the software name. What is it? Easy 68K now. Open up the software. If you have the laptop, download it right now. You can bring it home. Turn on your PC faster. This is where you will understand more. Turn on. Dah turn on. Easy 68K. Mas, satu lagi ni boleh naik tak? Ini besar. Saya rasa tak nampak pun. Kawin lagi ya? Okay, welcome to the simulator A368K. Alright, this is the simulator that you are going to use it later in most of your simulation program for the projects. Before you use the hardware, you have to do it over here first to